Hello and welcome. Good afternoon, good evening, good morning, depending on where you are in the world. Everybody, my name is Trevor Spires. I'm a solutions architect here at AWS, and welcome to another week of AWS Show and Tell with Generative AI. We do this every Tuesday night, believe it or not. And this week we got a fun episode in store. Before I hand it over to my guest and my co-host for tonight. I'll let you know I'm coming in from the great state of Maine today, and I know we always have folks dialing in from all across this wild world. So if you're here, let us know in the chat where are you watching in from, where are you tuning in from? Peter, let's start with you. Let the people know who you are, what you're going to teach them about today, and where are you coming at us from?
Yeah. Hey, thanks, Trevor. So I'm Peter Ildefonso. I'm a solutions architect. I've been working out of the HQ2 building and right outside of DC for about 5 years now. I have covered a lot of different types of customers. I know Trevor and I now work together in our financial services industry, but I've covered a pretty wide gamut, including all the way to agriculture customers on a farm working with cattle, and now I focus primarily on financial services. But today,
wait, hold up. We can't just wait. The cattle need the cloud. The farms need the cloud. We have to know, Peter.
Yeah.
What's the story here?
It turns out that the compression systems for milk cooling is actually much more efficient when you're using CO2 instead of more dangerous airborne gases. And those control systems need a lot more computerized and data-driven decision making. So we are able to cut out greenhouse gases and make milk cooling much more efficient using the cloud. So even dairies these days.
Hey, don't say you never learn something from this show, folks. We're already dropping really important agri-tech knowledge here. And we've got another guest, I think, for the first time. Vinny, why don't you go ahead and tell them who you are and a little bit of what we're going to talk about today?
Sure. Hey, folks. This is Venu Thangalapalli. I'm a solution architect at AWS. Been here. I'll be hitting 3-year mark this June. So I'm part of the financial services fintech industry. So working with the banking and insurtech customers. So happy to be here. And I'm based out of Windy City, Chicago. So we've been getting some great weather for the last few days. So I won't jinx it, but great weather, great stuff. So today we'll be diving into some interesting stuff where Peter and Trev, I'm sure you have some interesting stuff lined up.
Oh, yeah.
We're talking about Gen AI, right? and so, yep, bring it on.
Bring it on. I love the spirit, and that is absolutely right. Today we're going to dig into what I would consider to be kind of like foundational Gen AI knowledge, actually. Things that that a lot of people can rush into, but that I think if you're tuning in here, you'll learn a lot today about a few things. One, you're going to learn about the API structure of Bedrock, but also how we can configure Bedrock's API and take advantage of Bedrock as a managed service to offload a lot of the important kind of parts of managing generative AI applications. So we're gonna get deep into that very soon. But first, look, we got folks from all over the world today. Paraguay. We got folks from ready to learn about generative AI. People, if you have questions today, make sure to let us know in the chat. We'll be monitoring it throughout the session. We would love to stop for a second, catch our breaths, and answer any questions that you all have about generative AI or the service that we're going to be focused on today, which is the Amazon Bedrock service. Should I say else before we take off, guys? What else do we need to say?
And we've already talked about cows and Paraguay, so I think we're good to go.
We covered a lot of ground. That's right. We covered a lot of ground. Okay, cool. Well, then let's get started with the basics, folks, of like when you're calling the Bedrock API. I want to give you all a quick crash course on some of the kind of 101 here, and then we're going to continually crank this to go deeper throughout the session today. But if you don't know, Bedrock is a place where you can do a lot of things. All right. Think of it as a service that is your kind of like tool bench where you have tools to build with AI models, but also access to a lot of different, we call them foundation models on Bedrock, right? Now, that's awesome. Choice is amazing. Most generative AI applications are built with a broad, well, many successful AI applications, I should say, are built on a broad range of models. But that also introduces some challenges like, okay, cool, now I have to know Anthropic's API, and I need to know Meta, my Llama provider's API. There can be some deltas in how you interface with all the various models. And so a big part of what Bedrock does for customers is really unifies the experience of calling a model. And the specific API or endpoint with which we do that on Bedrock is called the Converse API. There are other ways to call models on Bedrock, by the way, but the Converse API has some distinct benefits, particularly as I'm talking about all these different models that are on Bedrock. You can get a single API structure that you can use across all of the models. So that means a systematic way to do things like call functions, right? If you've worked with other providers, you've noticed that you've probably seen that calling functions can vary from API provider to API provider. But on the Bedrock, you can have a single way to call a function or call a tool, for example, via the Converse API. And there's a lot of, I'd say, pretty important settings that you might need to adjust across models that are exposed via the Converse API.
So Trev, quick question. I know I get asked these questions a lot of times.
Yeah.
How easy is it to switch to, like, say, if I'm using a particular model and for a separate use case, I need to switch to some other model. Like, how easy is it with Bedrock?
That's a great question. Yeah, I mean, it's so simple. In fact, if you kind of zoom in, if you look at here, I'll add a laser pointer so we can see on Bedrock. Within the Converse API call, there is a parameter that you set. It's called the model ID. It's an important parameter, by the way. We're going to be talking a lot about some advanced capabilities today that you can access by changing that parameter. But to update an application that's built on the Bedrock APIs, it can sometimes be as simple as just changing the model ID. So maybe I want to switch from Claude 3 Sonnet to Claude 3.7 Sonnet, which is the latest version of the model. Or maybe I even want to switch models completely. Llama 4 just came out a few days ago on Bedrock. I know a lot of customers are really excited to access Llama 4 on Bedrock. Imagine being able to change a single line of code and then being able to test an entirely new model for your application. That's a capability I feel like it's easy to take for granted. But I was recently working with a customer. I don't know. Have either of you worked with customers that have tried to refactor applications from like one API to another? Because I've worked with a couple of customers that had to do that. It actually can be a pretty, it takes time and work to do that.
Yeah, and they have to sometimes create like, oh, this is one for Claude and this is is one for Mixtral, and like you see them having to create a bunch of parallel pipelines instead of being able to have that unified pipeline. You definitely don't want that duplication of work when it comes to like being able to switch in and out models.
One thing I heard from one of my customers, like a lot of overhead, and also they don't want to manage it, right? Which is a huge headache for the customer. So this makes it life a lot easier for sure.
100%.
And I know some customers also want that streaming capability. And it's important to note that Converse also has Converse Stream, which makes it so that you can stream data the same way you would with Invoke model with streaming. So if you're sitting there going, well, I like the idea of this unified model, but I still need to be able to get streaming data, the Converse Stream is still available as well.
Very good. Very good. I guess while we're here, while we're in this section, I want to talk about one of my favorite Bedrock features that can be that is, I don't know if I call it an extension. It's not an extension of the Converse API, but by adjusting some parameters of a call into your Converse API, you can start to access a lot of more, I guess, advanced, maybe like enterprise type features. Peter's going to walk us through a lot of some of the advanced configurations beyond just the basics of Converse here in a few minutes. But I'll show you a pretty obvious one. One that's built out of the box by Amazon is cross-region inference. All right. If you're not aware of cross-region inference, what cross-region inference is in a completely automated way, in a way that's completely abstracted and transparent to customers, using something called an inference profile, which you're going to learn all about today. You can set your model such that, or that model ID such that you're not actually hitting a specific model in a region, but you're hitting an endpoint that can load balance and fail traffic between regions. And while that may seem simple, it's actually a big deal for customers that need to do things like run applications in a highly available way to kind of spread out different fault domains for the AI applications. But also, we live in a world where there are chips spread throughout data centers all over the globe and all over the US. And leveraging something like this allows you to tap into all different pools of compute capacity that are setting across the globe. And so I want to highlight this feature because this is the sort of advanced inference that a lot of customers don't think of when they're just building their first application, building the first chat app on Bedrock. They may not be thinking about all of these more kind of fundamental ideas that we see in the enterprise oftentimes, like reliability. I think we're going to talk a little bit about authentication and RBAC, and I think Amazon calls it ABAC sometimes, and so I think we'll learn a little bit about that today as well.
And
Folks,
I actually have some customers that they come to us and they ask us, oh well, what if a region goes down? I mean, that's not a thing that really happens or has happened, but what if a component in that region has some access problems? Being able to say to them, oh yes, we already have this cross-region capability. It allows you to have that very rapid cross-region capability. That's something that customers at an enterprise level, that's like a starting conversation, not even, oh, we've now matured. But I do love this phase that we're in right now, which is everyone is now starting to get a little bit more comfortable with these apps and is starting to ask, okay, now how do I actually take them to production for reliability, for cost monitoring, for access? So it's a great place to be in.
Absolutely, yeah. The need. It's funny because I feel like I was in the phase last year where I was really just focused on helping customers get their first thing off the ground, and it wasn't until late last year. Yeah, some chat bots, some document processing, some kind of basic use cases, kind of like things that AI is obviously going to do really well for us. And then it wasn't until the customer's first outage where they started thinking about things like this. Like, oh, okay, we just took an outage at one of our providers. Like, that can't happen. This is now a mission critical application, And I think that's maybe how that is what I see starting to happen is we went from like a lot of the AI applications that were built were like nice to have apps, but when you're a customer and now there's an AI experience that's in what we would call like the critical path in financial services, where like a big part of how the user's interacting with your product is through AI. Now you need uptime for AI, just like you need uptime for compute and storage, right?
Right.
Yeah, getting those tokens available too is a big deal. So if you ever have token issues, I know that's something that a lot of customers ask about. Going to production, we want to make sure that we have enough tokens. I always warn people, make sure to talk to your AWS account team, whether you have a solutions architect or a technical account manager under support. They'll make sure that you're ready for the correct token count for when you do go to prod. Sorry, Venu, what were you saying?
Oh, no, I'm like, that's a great point, man. That kind of flows into what I'm going to ask as well. We discussed about switching between the models, right? So this kind of uptime also brings in a concept where, say, for some reason, I need to hit a separate endpoint, right? Or kind of spin up a separate endpoint to hit the separate model. This all needs to be kind of taken into consideration when you are kind of getting into that mode of, okay, how can we build this more high available and kind of towards multiple use cases? Any thoughts on that, or have you seen any conversations on that front?
I mean, I think when it comes to high availability, one of the things that you can see is maybe you don't need to be doing as much on the larger models. So having that intelligent routing, I think Trevor talked about it earlier, where you can hit an endpoint and then get routed to different models. So maybe the simpler model questions are routed to a smaller model. That way you're not having to deal with token limits. That way you're not having to deal with hitting these very large and sometimes larger latency and more expensive models when you could just be having a low latency, cheaper model that's doing the exact same job.
100%. And in fact, one of our audience members in the chat asked a similar question to this of kind of how do we think of like small language models versus large models? And like the way I think of it is like you got to use the right tool for the job. And unfortunately, fortunately or unfortunately, I'm not sure, but I know that what I see anecdotally is customers still tend to gravitate towards like launching and shipping on the largest, most intelligent models that are out there. I do think there's going to be a point where one of two things will occur. One, a lot of customers are going to realize they just don't need that type of like AI firepower, and they'll put it on a smaller model, because putting an app on a smaller model does two things. Yes, it makes the application a little bit faster, and engineers love that, but it also makes it a lot cheaper, generally speaking.
Yeah, I like a lot cheaper
on a smaller model. So at some point, somebody in the business is going to look at inference spend if you're launching everything on those large models and say like, hey, like, do we actually need the biggest, baddest model for our support chatbot? Or is that an application that might be able to get by with some kind of basic small model? But at AWS, to answer your question there in the chat, Cool, is like we're trying to give customers the options to build in whatever patterns they need to. I think a lot of customers do tend to start building on the bigger models. And then over time, as you mature, you start to get more sophisticated in how you can route traffic to different models. And in fact, I think we have a Bedrock feature that does just that.
Yes.
I was about to say, maybe on a future call, we can talk more about, like, there's actually a Bedrock feature that's specifically designed for things like Llama 7B versus the much larger one. Now I'm forgetting is it 80B? That you can actually have the router automatically route for you based on the complexity of the request. And then you add model distillation to that, where you have a much smaller model that's trained by a much bigger model using fine tuning. So like those are great concepts that are going to help people. But yes, you should look at multiple model types.
Love it. And I think with that, this is probably a good segue to like we're going to go a level deeper than Converse. We're going to talk about some more customization. Peter, why don't you tee off that discussion for us, man?
Yeah, so a lot of enterprises are starting to discover that what they really mean is to be able to approve models for individual applications. They have a process, yes, where they approve the model for the company. They go, yeah, we've looked into it and that one's okay. But now we need to make it so that applications and individual use cases get models, and we're making sure that they have monitoring for their individual use case. And we also want to be able to do cost attribution. So AWS does have a solution for that. We call ours application inference profiles. Trevor, I think we have an example of one that we can dive into. Yeah, so if you're not used to, let's go up one more. We can go to the next one, sorry.
Oh yeah, go ahead.
So this is what I was talking about. Like you are still going to have that process where an organization does need to determine, yes, this is a model we're okay with, and then opting into any of the documentation, the EULAs, things like that. But that's just for a whole account. Once you've done that for the account, you don't want to just have that blanket approval for a company at an enterprise level, let every single app run, because what's usually going to end up happening is you're going to have very restrictive policies. What you want to do is actually have policies that match each of those use cases, so that you're actually able to have those use cases be as successful as possible instead of just blanket approving everything. Again, that's at an enterprise level. We're not talking about smaller companies here, but when you start to scale, this is a big thing. What I recommend to most of my customers is have a request approval for an application to request access to a model. That's a pretty standard process, but have it be programmatic. Don't have it be an email. Have it be a basic system. They come in and they say, I'm this app and I want this model, or maybe they fill out the use case, whatever it is. That way, when the approval goes through, you can automatically generate the IAM role that's going to be necessary to access that application inference profile and generate the actual application inference profile. So that's why I have here, that should be programmatic. You should automatically be generating that. And we're going to show you some of this in the demo here in a moment. But moving on to the next slide. This is how simple it is. Just right here at the top, you see this create. You're going to AWS, Bedrock, create inference profile. You're giving it an inference profile name. You're giving it a source. So this is the model I want to use. And then there's optional tags. Now that's a big note here. It's one application inference profile per model. And if you're using tags, it's per model and per team. So that's why you want that programmatic process where you're automatically generating, let's say you have 5 models you're approving, you just automatically generate 5 of these. that make sense to everybody here so far?
Makes sense to me, but Peter, I'm looking around and I gotta ask you something, man. I'm in the Bedrock console. I'm poking around. I'm trying to find this thing called an application inference profile. I found an inference profile, but I can't find an application. Why can't I find this in the console today on April 29th, 2025?
So there is AWS managed inference profiles, which are literally the model ID that you would put in to say, I want to call this model. So that's what you're going to find in the console. Now, if you want to create an actual application inference profile that's going to give you this fine-tuned monitoring, the fine-tuned billing, being able to attribute things to tags, that's where you're going to have to do this through the CLI. That's why I have this CLI code here, is to just be able to show you that it's a quick code reference. You can use it in the SDK as well, but you're going to need to be able to do that through some kind of system or manually through the CLI to be able to actually do this for your users.
Makes sense, yeah, and I suppose the flow you were showing us before, it's like I think of this like, okay, I work at a bank or at a company that uses AWS, and I want to build a new application. Probably there's some central team that manages access to AWS and all these systems that will then, as a part of my request for whatever, maybe. In fact, I was going to say for my role, but I think we're going to talk a lot about how this relates to authentication. So I'll let you focus on that a little bit more. But I guess how does this relate to authentication and identity? Because I feel like that's something that a lot of customers want to figure out. How do I isolate access from between app A and app B that are hosted on Bedrock?
So when you think of an application inference profile, you're thinking of kind of like a boundary that you're setting, and you're saying, I want this app to be able to work within this boundary. Now, you can have multiple apps that work within that boundary. The way that you're going to set that boundary, one of the ways you can do it is through tags. The other way that almost everybody's going to do it, and even if you use tags, you're going to have to do it anyway, is through IAM. Obviously, it's through IAM. That's how we do most access controls here. So if you go to the next slide, I can just walk very quickly through what we're looking at here. But IAM is actually the core of how you're going to control access to any of the application inference profiles. So this, if you're not used to this is just how IAM policies are structured. You'll see two here. So that is normal. Don't worry about that. And the first one is saying, hey, I want to be able to allow invoke model and invoke model with streaming. So that's why you see that star. And then the line under resource says for any application inference profile. And I have a condition here that says I want the resource tag, which is the thing calling, to match the principal tag, which is the thing being called. And so, the other way around. I, the person calling, want to make sure the app that I am using to call matches the resource that I'm calling. So that those are ways you can do this. It's again, this is an optional, this condition here you see, where you can write this once for access-based, role-based access controls, or tag-based access controls, or attribute-based access controls, whatever you want to call it. You can use this once, and then you don't have to update this IAM policy for each of these inference profiles, because the person calling it has a tag, and the application inference profile has a tag. And when they match, they're allowed to do it. So if they try to call an application inference profile, which is a model, without that tag matching, then they don't have approval and it's going to get rejected. Now, the second policy we see here, I want to call out, if you're in the process of doing this, we're in the process of updating our documentation to help you with this. This is a specific place where I've seen some customers struggle. You do need to allow access to the foundation models in addition to allowing application inference profile access. So that's why we just have this basic policy here. And it says, I'm going to give you access to any foundation model that you call, as long as it's being called through an inference profile ARN. So you're using an inference profile to call a model.
You know what's funny is I think maybe one of the most common reasons that a customer reaches out to me because they're getting an error from Bedrock is because they did miss that one step of actually turning on access to the model in the given account or region where they're trying to invoke the model. It's an easy step to forget. I actually forget it myself often when I spin up a new account, and then I have to go back in there and go through it. But
yeah, so You just need these two policies. You're basically saying allow them to invoke, and allow when they do use invoke, make sure that they're actually using an application inference profile. Just to clarify, if you didn't even care if they accessed it through an application inference profile, they could do it through the model or the inference profile. Or if you didn't care which one of the inference profiles they access, you could remove both of these conditions here. But at some point, you do need to add something that says they can access the inference profile and they can access the model.
So is it more like, Peter, as a sandbox, if I'm just getting on the path of testing it out, open it up, then kind of granularly fix it, or like once you get into dev, right?
Yeah,
Because,
you're going to have to play with it. So depending on your tagging strategy, if you do use tags, you need to make sure your resource tag and your principal tags are done the same way as this is set up.
Yeah.
Again, I have a tag on the role that's being used to call it, and I have a tag on the application inference profile. That's what the two here that are matching. If your security structure isn't done that way, you're going to have to modify what's done there.
Yeah.
So in that example, I'd play with that in Sandbox. But yeah, other than that, yeah, this is a great place to strip those two out and then go play with it if you have that access. So let's jump to the next slide. The benefit here is that you are actually going to take out the model ID where you see here we're calling Claude 3.5 Sonnet. You're actually just going to take that out and put in the application inference profile ARN. So you're only changing that one line, and you're saying, hey, Bedrock, I'm calling a model, but you already know which model it is because I'm giving you the ARN of the inference profile. Remember, the application inference profile is tied to one model. And so this will give you that ability to just swap that code out. And now instead of just getting all of the details of monitoring, of billing and all that under one big umbrella, the Anthropic Claude 3.5, now I get it by each individual inference profile. You can also look at it by the big model grouping as well. But if you want to do it by each individual inference profile, you can do it that way now. So this helps for much more granular CloudWatch logs, and it helps for billing.
You know what I'm thinking about? I really like when there's a path, like, because obviously this is something a lot of customers will need to do for identity, for billing, for a lot of other reasons. And I love when there's a clean path to go from like, I built it the obvious way that maybe wasn't the right way to like transitioning. So like if I had already built my app and I was just hitting the model directly, transitioning to something like this is like a simple change of updating the model ID, and it should have no impact on my application law while allowing me to get all the benefits of having the advanced inference profiles in place.
Right, and that's still gonna give you that granular billing. It's gonna give you that granular monitoring. But yeah, you just change this one line, and as long as the model ID that you're referencing in the application inference profile is the same model ID you were referencing before, then it will continue to operate the same way. Because what we're doing is we're just obfuscating this for you. We're saying, okay, you're using this inference profile, and then we're calling the ID that's linked to it. So those will be the same.
A quick question, Peter, on that. Have you heard any common patterns of misconceptions with this? Like, oh, okay, I have to rectify this, or I have to enable the end user on this.
Yeah, I mean, I think one of the biggest concerns customers have is, okay, so I was having trouble tracking, all of the model IDs. Now I'm going to have a bunch of application inference profile IDs to track. I recommend in that approval system just having either a basic DynamoDB or a system in Systems Manager. There's a place to store keys. I recommend putting that into a system like that, where a developer is not really having to access, a more complicated, like, oh, what was my ARN again? Maybe you just have it for them where they're selecting from a lookup, and then you call that DynamoDB table and actually pull that on the back end for them. That way, they just have to pick the model or something like that in order to manage it. But hopefully you're not getting to the point where there's so many of these that per team, per model that you're not able to manage them. There aren't, I mean, there's a lot of models available, but there aren't thousands.
Yeah, I mean, and in general, I think still it's like, I feel like if you automated it, it makes sense. And a lot of this comes down to the question of like, are you doing like centralized inference on Bedrock, where you have a single account that a lot of your applications are running inference through, or do you have a more decentralized inference model where you're spinning up AWS accounts and building access to Bedrock from the context of that one account? I see this being particularly important for customers that are building in a centralized pattern where they have a lot of different teams that may be hitting the Bedrock API in a single centralized account. Like I'll see a lot of customers that have like a AI platform team that have an account that will run all of the inference. So you need some way to organize that.
And maybe the billing isn't why you do this. Maybe it's the monitoring that you do this for, where you actually have individual use cases and you want to know their latency or their token usage. Maybe it is the billing that you're focused on and you don't really care about the monitoring. You get both of these out of that. So it just depends on what your use case is. So I think we had an example real quick of the actual monitoring that you get directly from this. Do you want to show that real quick, Trevor?
Sure thing.
So just for your awareness, you can do things like you can track output tokens, you can do things like track latency. And as you see here, these labels, those are the inference profiles. So you can actually see by inference profile what you're actually getting back for individual use cases. So I think you want to jump into the console now, Trevor? Is that a good transition?
I think that's a great transition. I think folks would love to see this in action. I would certainly love to see it. And I'll tell you, what I hope to see is like I like the idea of being able to do some identity-based enforcement. So I'll be interested to see if you have some way to block folks that maybe don't have the right permissions. But we're looking at your Isengard now.
Yeah, so I'm logged into an internal AWS account. It's one of my accounts. And I start here because I want to make sure to remind people, you do still need to get model access approval in Bedrock in order to be able to use any of these features within Bedrock. And right now, because of the EULA and the way that the approvals of the EULA contract works, you do still need to do it directly through the console. So if you come in here and you see a model that you want to get access to, you can simply come in, see that model, and request access to it. Now, I'll pause right here. If you have a company that requires EULA validations through your legal department, make sure not to just randomly click approval for this. Make sure to follow your internal company policies. But that's what I'm doing here, essentially, is saying, yeah, I do want to approve these EULAs.
EULA, more like YOLO. Click approve for those EULAs. No, I've actually seen. What's interesting if there's anybody here that actually dig into AWS, like and are managing AWS organizations in a big enterprise. Interestingly enough, this is actually a marketplace permission for most of the models to go in and approve the model because of what Peter's talking about here. These are, with the exception of those 14 models underneath the Amazon section here, all the rest of these models are either managed by a third party like Anthropic, or they could even be open source managed by us. And many of them do have their own end user. I actually don't know if the Amazon approvals require marketplace IAM permission or not. They may require the same permission. I actually need to dig into that now that
I'm not sure, but luckily these other models, instead of you having to go through the marketplace and finding the right offering and getting approved, this is all just baked into Bedrock now.
Yes.
So once you do this is the last time you'll ever see anything about marketplace.
That's right.
Now that I have approved,
friend, quick question: like, how soon will this be available? Like, say, okay, if someone goes in there, clicks that, like, how soon can they be able to access those models?
I don't know if you saw it, but I clicked request access and I already have that access. Okay. Now, I'm not going to say that's going to be immediate for every customer, but they are generally very fast. And it's not you waiting on Amazon to get these approvals. Usually it's you waiting for your company to validate they're okay with it. The URL. So, but if your company's okay with that, or they've already reviewed it, that's why I recommend have a company process for reviewing these for the whole company. Then you don't have to worry about it. You just come in here and request them. I have never personally seen this take more than a couple seconds. Not to say that I wouldn't, but I've never seen it. People do that.
Okay.
Now that I have the model access, I want to talk to you about those IAM policies. So now I'm switching. I'm still in my console. I'm still in my account. But now I'm over in the IAM policies section, and I'm looking at one specific policy that later we'll show you is attached to a role. And so a policy document is basically saying this is what the role is allowed to do. And so what I've done in here, and I'm going to zoom in for everyone to be able to see. Oh, now it's jumping. There we go. I'm going to zoom in for everyone to see. You'll see here that it has invoke star here, and I have application inference profile tagged to the principal ID. That's the same thing we showed you earlier. I also have invoke model for the foundation models, and it has the inference profile ARN. So again, this is what I showed you earlier in the slide, but this is it live and in person. And it's just basically saying, yes, you can access an application inference profile if it's one that aligns with the tag. So you have a role within this app ID, and you have a application inference profile within this app ID. So obviously they're allowed to work together. And I'll show you where they don't work together. And then obviously I need to be able to allow the underlying invoke. And so you would need to set up one IAM policy with this same pattern for each of the applications. So an application invokes a role. That role has a tag on it. That's the kind of boundary you'll need per application, but you only need one. And the way that we're structuring this and talking about this today, you don't have to customize each of these individual documents. All of this stuff you see here either has stars or has that variable, so that you don't have to actually get this IAM policy approved through all of your structures over and over again. It's just the same policy. And so I have another one of these that, but this one is attached to a role. So the role here that you see is just simply called the invoke inference profile only for Bedrock. And this is the one that I just told you about that I attached. And so if we look at this in the code, again, we see inference profile, and this is a different role. But again, it can just have this generic code in here because the way that we're using the tags.
By the way, while we're running through this, we have a couple of interesting questions in the chat. Somebody was asking, I think they were asking this as we were approving the models.
Oh, yeah.
It's not just somebody. It's not just anybody. This is a dear friend of mine, Isaiah. But he wants to know, can you limit like how many models a company can use in Bedrock? I guess that's an interesting question, just in terms of how, like, the way I interpret this, or what are the different, because the answer is yes, but what are the different ways that you can limit access to a model in Bedrock? I think we're looking at one right now. We saw the high level, just you can enable and disable models across an entire account within the Bedrock console. I think there's some other ways too that you can.
IAM is like the way that everybody really would. I mean, you could block it at that. Like, obviously, I didn't even approve the EULA for it, so obviously no one can use it. But that's not a great like scalable or like aligned with how your other approvals work. So I would keep it in the IAM family and follow whatever standard access patterns you have for IAM. But yeah, you could limit it if you really wanted to.
And the interesting way is like through org-wide, right? Organization-wide, using service control policies, right? And there are more granular aspects that you can restrict what business unit can access certain models. That's one way to do it. But yeah, IAM, SCPs, another one, I think, like, probably a couple of ways. But yeah, definitely there's more. But you need to do
and so you see here that I have this Bedrock 2 that's got the app ID is 12345, and then I have this Bedrock profile for developers 3, which is 9876. So those are the two app zones that I've created in this account to show you. And so I'm going to jump over and jump into the actual function that we're going to use to actually call. So for those of you who don't know, I'm in a Lambda function right now. A Lambda function is what some people call serverless. There is a server, you're just not managing it. Don't worry about that part. And within this serverless construct, what we're doing is we're able to actually write this code up and test against it using Lambda. So if you look here, and I'm going to zoom in quite a lot, we talked before about being able to use Converse. We also have this capability here to use invoke model with response stream. So it just depends on which command you're using. I'm using invoke model with response stream command, which is actually the SDK's version of the Converse. But we're not going to talk too much about that. What I do want to focus on is what this is calling. So you can see this params here. That's where I'm setting all of this for this Anthropic model. So I'm focusing on using Anthropic model. And right now what I have is an application inference profile. And that is the only real specification I have in here to tell this to actually what to call. We talked about earlier how powerful this model ID is. And so I actually have another example here that's commented out where I would be calling just the base model. And if you remember, when I set up the IAM policies, what I said was in the IAM policies, you're allowed to call the model, the base model, as long as you have a defined application inference profile. So if I was to comment out this model ID and just try and call the base model, this is going to fail. And so the reason why this is going to fail is that I am not, again, allowed to call any of these. Let's show you this real quick. So I come over here to test. I drop in my test code right here. Everybody loves what is the meaning of life. I haven't gotten any Gen AI to send back 42 yet, but I am still waiting on that. And I can click test. And what I'm doing is I'm executing the function, but again, I'm executing it directly against the model. And so while it says succeeded here, you can see that it does come back with it's not authorized to perform this. So the Lambda function succeeded in the actual API call failing is what this means. Versus if I come back over here and like I showed you in this code, I actually comment back out that model ID and I make sure to call an application inference profile that has that model ID's ARN included in the application inference profile. So this is the way that you would want to set this up. Now when I actually test against this, you'll see that it's going to take a little bit longer because it's actually doing the full back and forth. And what you're about to see is what the raw streaming response looks like from a model. And so a lot of this stuff is just the data that's coming back and the stream handlers. And you can see this text over on the side here is the actual response that comes back. Of note, at the bottom here, you'll actually, for one of these calls, you'll get things like first byte latency, total invocation latency, output and input tokens. Okay, so again, what I did here was this application inference profile has a tag on it that is 1, 2, 3, 4, 5, and I am using a role to call that tag that has application ID equals 1, 2, 3, 4, 5. Now, what happens if I try to call a model I'm not approved for? So this right here is the application inference profile for the project 9876. And so I don't, as my tag, my application ID and my tag is not going to match that one. And so when I actually go to call it, even when I call this, it's technically calling the same underlying model. I'm not allowed to use that team's application inference profile. And so again, you'll see here, not authorized to perform this activity. So I know that was a lot quick, but again, you have the ability to do this by application inference profile with tags, or you can just make it optional where you don't have to enforce the tag security, and it's just using application inference profiles to be able to keep those segmentations. And you get a lot of great metrics. Again, as we talked about, I found that using things like invocation latency and having some alarming on like a high invocation latency is good. You got to watch out if you have a really big model, the total invocation latency is till the model's completed. So if you're having a big request going in and it's doing a complicated task and it's spitting out a lot of data, that's going to be a naturally larger invocation latency. But you can also do things like invocations and total tokens, and depends on what you want to track. But you see here these labels, these are the same application inference profiles that we saw here. So I'll see me over here. So we saw, which one did we just call? We called the NO44. That was the one that got rejected because it's not the correct tag. But what we did call successfully was the Wi-Fi I2. You'll see over here the Wi-Fi I2. I've been calling that all day. So there's plenty of that data that's coming in that I can see. I know that was a lot. If you ever are interested in more data about how these in particular conditions work, these are called IAM condition keys. And in the actual Bedrock documentation, if you scroll to the bottom of the service authorization documentation, you will actually see that we cover all of the different condition keys that you can do. So it doesn't have to just be, oh, the thing I'm calling from the role matches this resources tag. You can do a lot of different, maybe if it only has this application ARN or something like that. That's where you see this inference profile ARN.
If you go back to the CloudWatch for the different, so this is also a way, I suppose, for you to monitor, like if I had a few different applications and I was a central inference team and I wanted to see like which one is using the most inference. I suppose there are other ways to do that with like invocation logging, but I think those solutions seem more complex than just using the inference profiles themselves.
Yeah, I mean, if you have two teams that are calling the same model ID, all of the data is going to be lumped under that one model.
Right. Yeah.
So if you really want to see which team is using it differently, you have to really focus on these application IDs. So like one of the big ones I know people like to see is like input and output tokens. So like let's look at input tokens by model here, and so you'd be able to come in here and really see, okay, that last one was 14. So I've been using the same one, so it's going to keep being 14, spoiler alert. But yeah, I mean, it's you'd be able to see those tokens and see, there's going to be probably a lot more of these invocations per actual time frame. So you'd be able to see that by app. Or if you said, no, but I really do just want to know like by model which one's being used, you could just switch and look at it by model. So I have
yeah.
And
I think that's an important something that I think we were talking about earlier is like when you manage capacity in Bedrock, you're managing capacity on a per account basis.
Right.
And so if you're like it's almost like different personas that I'm thinking of, right? Like if I'm a central like AI and ML platform team and my job is to give developers access to models, I'm mostly thinking in terms of what are the input and output tokens being used across this model in this account, because that's where my capacity is tied to. But a great way, I see these as being a great way to have a better understanding of what different apps are using a model. So that way you can start to project like growth of different apps, because the growth, like, when you're managing many different apps on a shared pool of resources like this, especially at scale, you need to be able to have that type of per app or per team, I guess, depending on how you slice it, visibility. And what I'm hearing is you can slice this really just about however way you want. As creative as you can get with tags is how you can slice it up, really.
Yeah. I think one is great resource management with this tagging and inference profiles. And the one is like, it actually gives us those deep dive on the cost tracking as well, which is a huge aspect with Gen AI or these apps, right? So those two are
you're going to get a team somewhere that's going to say, I'm not spending that much, and the other day, well, we're not spending that much. You gotta have somebody actually be able to say, no, you're spending this much and you're spending this much.
Yeah, totally. I have literally seen a customer that has like a multi-tenant environment where they have like a really important application that and then they have an unimportant application. And the unimportant application was like DDoSing the really important application. But the unimportant application team didn't want to say like, oh, we were actually just like throwing a bunch of test traffic at this to see what it could do. And so I think that's a great, it is important to have that. I think one thing I hope that comes in the future is some ability to maybe do like application profile based rate limiting or something like that, where you could actually say like with this one, I almost could think of it similar to like API gateway, how you define like an API key that has like
throttling,
different RPM throttles and stuff. I can see that potentially. like I'm thinking if I was going to put that in Bedrock, I think maybe this is where I'd put something like that, just based on now we have this application focused construct there.
That's a great feature request, so
all right, I'll file it right after this.
Folks, I can't tell you the number of times that the customers come and they say, it's slow. Okay, so what does slow mean? Okay, so now we can define it. Now we have a latency for this app, for this model, and we can really say, for me, I needed half that latency. Okay, well, now let's talk about smaller models. Let's talk about model distillation, all that stuff we mentioned earlier. Let's not just have this abstract, it feels slow conversation.
Oh, we've all been there. We've all been there. From virtual desktops to LLMs, it feels slow. Never
stops. Yeah.
Folks, if we are going to open it up to questions on anything you saw today on Bedrock Inference at Scale, we would love to take a few moments to hear from you, folks in the audience, folks that are watching along, to see is there anything that you want us to dig into in the last few minutes that you have us here. While we're waiting for folks to ask in the chat, Vinny, Peter, what do you think? What else do folks need to know that we haven't covered today about Bedrock Inference?
I mean, I think the big thing here is you need to have a plan. So if you were going into, I'm going to need to scale, start thinking, what is your plan for that? And how do you want it to be structured?
Yeah. In fact, this question from James really is a great question that makes me think about how you might scale this with a customer. And he asks, how might you use these application inference profiles in the context of an agentic workload, for example?
Yeah. So if your agent is so let's clarify, because I know this has been a big miscommunication on some industries. Is you can have an agent that runs Gen AI, but you don't necessarily. An agent can be an ML function that's not necessarily Gen AI. So if you have an agent that is running Gen AI underneath, then you could use these application inference profiles to define a boundary for your entire application. So using those tags, using those kind of constructs, now everything falls under that same tagging. And so you actually know the price of that whole, not just individual agent Gen AI use case, but the entirety of the agentic workflow.
Great. Yeah, and even as agents develop, I'm seeing patterns now. A year ago, I was like, is this a buzzword? And now I'm like, no, it's not a buzzword. It's a pattern. Is this idea of sub agents. And so I could even see maybe some structure in these where you have the parent agent who maybe this is the HR tag, and then there's sub department or sub team tag distinctions within that as the agent becomes more complex over time.
Yeah, and that's a superpower, I believe. I'm just thinking out loud. Fintech, SaaS, multi-tenant customers, these kind of actually helps them with the tagging strategy as well, and granular cost tracking and permissions, right? With IAM, SCPs, it's all well built there. So that's a superpower I would take.
Got a great question from my bud. He's back at us, Isaiah. I love this question because I feel like if you really understand the answer to this question, it's like a light bulb for how AI apps are actually designed. But either you all want to take this question from Isaiah?
There's a lot of different ways to do this. I think the gut way that a lot of customers are going to do is just build their own kind of endpoint and then manage all that code. I've seen a couple customers do that. This is where I was talking about earlier, where if you have the ability to do model choice, where your intelligent routing is being managed by Bedrock, or you have the option to maybe test with a bigger model, move to a smaller model. That's where I would try to avoid custom managing all of this, particularly given that it's not something that's going to be we're expecting customers to do themselves.
I end up seeing this. I don't know. Is it called shifting left? It shifts all the way to where it tends to be what I see as the application teams that they'll have their software written, and different pieces of their software will call different models. They'll have learned this model from Anthropic is really good at this reasoning intensive task, but this model from AWS can do the same things but cheaper. And so I almost think of the mapping between a model, like I think about the mapping. Here, let me zoom out. Here's what I think about. Each Gen AI app is a series of different prompts, and different models might be better at different prompts.
Yeah.
100%.
I think of it's the prompt to model mapping is loosely like 1-to-1. And I'll leave it at that, so I don't end up
And
over.
to be honest, we didn't even talk about it here, but custom models are a whole nother like can of worms here, where you could have a very fine-tuned custom model you're having Bedrock manage, and your application inference profile is calling that custom model, but that model is maybe a lot smaller, a lot different. So like you could have hundreds of those running in theory, where you're actually running those in an agentic workflow. But again, you could unify all those through tags. You could unify them all through application boundaries.
The potential is seemingly unlimited, folks. And people, we're going to wrap up here in just a second. First, we're gonna allow our guests to say goodbye. Tune back in next week, same time, same place. And we're going to be digging into more generative AI topics next week. I believe we're digging back into Amazon Nova. So thanks, folks, for joining. This is wild. I agree, Isaiah. Venue, Peter, thanks so much, guys, for joining along. Any parting words? Any quick parting words to our guests before we send them along their way for the evening?
I think Werner Vogel always said it best. Now go build. So get out there and start building.
That is right. That is right. Go and build. Thanks again, everyone, for tuning in, and we will catch you same time, same place next week. All right. Take care.